Yes, students, now we are going to see about access specifier in object-oriented programming. Access specifier. What do you mean by access specifier? There are three types of access specifier. The main objective of access specifier is to protect the data from the external environment. That is, we are going to secure our data by giving the three keywords. What are the three keywords? Private, protected, and public. Private, protected, and public. These are the three keywords which are available to protect our data. Excuse me. No? So access control. So if you are going to give private as a data member, the data member cannot be accessed outside of the world. Within that block, it can be accessed. Outside of the block, it cannot be accessed. That is the wonder of giving private access specifier. In some cases, if you forget to give any access specifier, what will happen now? The compiler automatically it will protect data. Automatically it will assign as a private if you forget to give access specifier. If you're going to give public, then it can be accessed outside of the world. If you forget to give any access specifier, by default C++ compiler it will take as a private access specifier. Here you can see public member is accessible from anywhere outside the class, but within the program. Yes, within the program we can access. Even outside of the class, the public member can be accessed. Now come to the private. The private member variable or function cannot be accessed or even viewed from outside of the class. So as I said, if you forget to give any access specifier, by default the compiler it will assign as a private. So as a private data member, it cannot be accessed outside of the class also. Only the class and friend function can access the private data member. Now come to the protector. So protected member variable or function which is very similar to the private member, but it provides one additional benefit that can be accessed in child class. That means protected data member can be used between the two classes. In inheritance only it can be accessed. So private lies between private and public. So this is an example one to understand the access specifier. Here you could see class name is line, um, public data members are length, set length, get length. So this is end of your base class. Base class name is line. Now come to the main function. We are creating object line for your class capital LINE, and here what the access specifier that we are using? Public only. So whatever data member that we are using in public, it can be accessed outside of the class. Hence, the set length can be accessed outside of the class. Same example. Here you could see class name is box, public access, public data members are length, set width, and get width, whereas double width is given under private. That means this width cannot be accessed outside of your class. Okay, here you could see here in main program you try to access the width with help of the object box equal to 10. You will get error message because width is private. Width is private. If it is public, there you won't get any error message because it can be accessed outside of the class. As a case here, private which cannot be accessed outside of the class. So that is the wonder of giving private access specifier. The data cannot be accessed outside of the class. Come to the example 3. This example 3, you could see same class name box protected as with. That means the protector is a data member which can be used in inheritance within the two classes. Here you could see base class name as box, and derived class name as small box, and derived class name as small box. Base class name is box and derived class name is small box. In small box is going to have its property as well as from base class property. Now come to the main program. You are creating object for your small box because small box contain its property as well as base class property. As a result, you could access this protected with access the protected it, because between the two classes we will be able to access them. Now come to the interesting topic, friend function. Interesting topic, friend function. What is friend function? Friend function is a non-member function. That means that is not belongs to any other class. Friend function is a class of defined outside the class scope, but it has right to access private and protected member of the class. As a result, it's violating the OOPS feature. What is OOPS feature? Private member cannot be accessed outside the class. Whereas friend function, it has right to access. It has right to access the private data member. As a result, it's violating the OOPS feature. Okay. So here the friend function of a class is defined outside that class scope, but it has right to access all private and protected member of the class. Even though prototype for friend function appear in class definition, friends are not member of function. It's not a member function. A friend function can be a function template, or a member function, or a class template in which class, the entire class, all of its function. So this is the example for friend function. Here class name is XYZ, private member is 100, and here you could see public friend void display XYZ object. So this void display is a non-member function. Why non-member? Because you are giving friend. Friend is a keyword. Friend is a keyword. That friend function can access the private data member. As a result, it's violating the OOPS feature. Come to the definition part. Here you could see the private member num here, object.num, and you are accessing that object.num by displaying the obj by calling display function, whereas display function belongs to the friend function, but it accessing the private data member num. So the concept behind friend function is that it's a non-member function. It has right to access the private data member. As a result, it's violating the OOPS feature. Now come to the inline function. What is inline function? Inline function, C++ provide an inline function to reduce the function call. To reduce the function call. That means no need of transfer of control. No need of transfer of control. Automatically the member function will be expanded. Automatically the member function will be expanded. Inline function is a function. Inline function is a function that is expanded inline whenever it is called. Whenever it is called. When the inline function is called, whole code of the line function get inserted or substituted at the point of inline function call. This substitution is performed by C++ compiler at compile time. So the inline function is a function in which it's going to expand inlinely rather than transfer of control. Rather than transfer of control. So inline function that expand inline when it is called. So when the inline function is called, whole code of inline function get inserted or substituted at the point of inline function call. The substitution is performed by C++ compiler. Inline function may increase efficiency if it is small. So this is the comparison between ordinary function and inline function. Normal function, whenever you are going to call, the control will be transferred to definition of your function and it will come back to your original position. Whereas in inline function, the main function body is executed. When you are going to call my function, there is no transfer of control. Automatically the code will be substituted. Whereas ordinary call, whenever you are going to call, the control will be transferred to the subprogram and it will execute and it will come back to next line of your function call. Whereas inline function, there is no need of transfer of control. This is the advantage in inline function. So here you could see main function. You're calling max 3 times. The definition of max is given here, which is declared under inline. So what will happen whenever you're going to call max, here itself the function will be expanded. The function will be expanded. No tensor of control. This is all about inline function. Thank you.